Good morning friends. In the last period we have studied about the line integration and the surface integration. The line integration we have to study about the curve or closed loop, and when it is closed loop it should be considered as a it is equals to 0 at that time, it is irrotational. And then after that we have to consider the surface integration over the surface S, that is f bar dot n cap into ds is equals to fx into dsx plus fy into dsy plus fz into dsz. And this is the two integration we have discussed in the last period. In the today's lecture we are going to discuss the 3 points. Number one, we have to discuss about the volume integration. Then that volume integration and surface integration is used for volume integration, line integration and surface integration used for the two theorems. And these two theorem statements are we are going to discuss here, because many times multiple choice question may be asked on that. That is Gauss divergence theorem and a Stokes theorem. These important points we are going to discuss today here. Let us consider a closed surface, and at that time space enclosed by the volume is say V for a point of the function say a bar, and then we have to say that let a bar is the vector field. A bar is equals to, what is the vector? Ax into I cap plus ay into j cap plus az into k cap. This is the vector field we have to say that for vector, that is a bar. Then volume integration of a bar dot dv is defined as, then volume integration of a bar dv, or we have to say that a bar into dv is defined as, what we have to say that, but dv is equals to what? Volume, and that is dx dy dz, and dv is equals to a bar is equals to this, dv is equals to this. Then we have to write that volume integration of volume integration means a triple integration, line integration is a single integration, surface integration is a double integration, volume integration over the volume V, a bar is the vector and dv is the volume of that vector field. And then we have to say that is volume integration over the x, y and z. The vector is, we have to say that x into I cap plus ay into j cap plus az into k cap, and dv is nothing but dx, dy and dz. Now separate the integration. What we have to get, that I cap, j cap and k cap, we have to take on the common factor. Therefore volume integration of a bar dot dv is equals to I cap into, what we have to say that, first of all we have to take the integration over the x side, that is x, y and z. This is what we have to say that ax. First is we have to say that ax into, we have to say that dx dy dz plus j cap into triple integration x, y, z, that is ay dx dy dz plus triple integration x, y, z, az dx dy dz. This is considered as a volume integration. We have to find the volume integration of any vector field, that is a bar, f bar, what we have to consider v bar, and then we have to write that in this way. We have to write the formula for the volume integration. First of all we have to study the formula for line integration, then formula for surface integration. This is the third formula we have to discuss, that is called the volume integration. Now we are going to discuss some problems on this also, but first of all we have to discuss the Gauss divergence theorem, and that is Gauss divergence theorem. That is theorem is enable us to transform volume integration into surface integration. Transform volume integration into surface integration. multiple choice question may be asked on that. What is the use of Gauss divergence theorem? The Gauss divergence theorem is used to transform the volume integration into surface integration. Remember, Gauss divergence theorem is used to transform volume integration into what we have to say that a surface integration. Divergence is what we have to say that a del operator. What is the del now? Del is nothing but we have to say that F bar is the one of the vector field, and then F bar is equals to what? I cap into Fx plus J cap into I cap into Fx, J cap into Fy plus K cap into Fz. This is what we have to say that F bar is the vector field, and divergence is the del operator, and del is nothing but what we have to say that del is nothing but I cap into dou by dou x plus J cap into dou by dou y plus K cap into dou by dou z. And this symbol is called as divergence. In the last one period we have to discuss about the divergence means a dot and curl means across, means Gauss divergence म्हणजे ह्याच्या नावामध्येच डायव्हर्जन्स आहे. म्हणजेच we have to say consider that F bar is the vector field and del is a divergence operator. Divergence of F bar into dv is equals to what? F bar dot n cap into ds. This is the statement we have to say that divergence of vector field F bar integrand over the volume. Divergence of vector field F bar integrand over the volume say V is equal to surface integral of vector F bar. Means we have to say that Gauss divergence theorem states that Gauss divergence theorem states that vector field F bar integrand over the volume V. Vector field F bar integrand over the volume V is equal to integrand over the volume V is equal to surface integral of the vector F bar, surface integration of vector F bar over the surface S surrounded by the volume V, over the surface S surrounded by the volume V. And this theorem is considered as a statement of Gauss divergence theorem, and it is used to transform volume integration into a surface integration. This theorem is called as what? A Gauss divergence theorem. And here V bar is the volume, F bar is the vector field, and having formalized this one, del is a divergence operator. So divergence of F bar into dv is equals to surface integration of F bar dot n cap into ds. Means we have to say that Gauss divergence theorem is used to transform volume integration to surface integration. The proof of this theorem is also there, but we are not interested to discuss the proof here. Just we have to remember the theorem statement, and then we have to discuss about the last one more article in this chapter, that is a Stokes theorem. Now, what is the use of Stokes theorem? The Stokes theorem is used to transform line integration into surface integration, or vice versa. Means surface integration can be transformed into line integration. This theorem states that the integral tangential line integral of the vector function V bar. Let V bar is a vector function. Let V bar be the vector function, and then we have to say that over the closed loop is considered as say C. This is over the closed loop C. The line integration over the closed line integration of vector field V bar over the closed loop C. Line integration of the vector tangential line, the tangential line integration of vector function V bar over the closed loop C is equal to normal surface integration of the curl of the function. Is equals to normal surface integration of the curl of the function. This is called as what we have to say that curl of the function. The function is what? V bar into n cap into ds. Curl of the function v bar over any closed surface, and mathematically we have to say that v bar dot dl bar is equal to surface integration of the curl of v bar into n cap ds. This is called as a Stokes theorem. The Stokes theorem states that let us consider the vector field v bar over the closed loop C is equal to the surface integration of curl of vector field over the closed surface S. This is called as a Stokes theorem, and the Stokes theorem is used to transform a line integration into the surface integration. This is the mathematical statement we have to say that v bar dot dy line integration over the closed loop C, v bar dot dl bar is equal to surface integration of curl of v bar dot n cap into ds, where n cap is the unit normal vector to the surface say ds, and this is v bar is the vector function, and then dl is considered as the length element. And from this we have to prove this theorem by using the mathematical vector contribution used to transform the line integration into the surface integration, or we have to say that is surface integration into the line integration. In this way, this chapter is we have to finish here, and multiple choice questions we have to given on the PDF of the Monday's lecture. All the questions are very important. We have to solve that questions, and also numericals we have to discuss in the last week. So these numericals and these multiple choice questions, in this way we have to finish the chapter number say 1. Thank you.